Okay, so today we're going to officially introduce the other trigonometric functions. First, let us remember what our original trigonometric functions are. Here is a right triangle with angle alpha, and here's our 90 degrees. This is y, this is x, this is r, which is the radius of a circle, which is why it's r and not h in general, although I've said that a few times. Strictly by definition, the sine of this angle alpha is y divided by r. And the new thing that we're going to define today is called cosecant, and it's listed like this, CSC alpha. This is just 1 over sine alpha. It's essentially sine alpha upside down, and this is equal to r over y, where it's defined, right? Y obviously can't be 0. What else do we have? We have cosine of alpha is equal to x divided by r. And now we're going to define secant alpha, which is 1 over cosine alpha. So this is just r divided by x. Obviously x can't be 0. We're going to talk a little bit about where these are defined and where they're not. And we also have tangent alpha, which we know is y divided by x, or it's the slope right here, and this is y over x. We're going to define cotangent alpha, which is 1 over tangent alpha, so this is just x divided by y. You will definitely have to know these. These are going to show up. They're going to show up a lot in calculus. So that's that. Maybe we should try. Well, I'll not worry about the graphs so much right now. Let's just try and do some calculating with these. So I decided to spice this up with many more of your homework problems because a lot of people were asking me to, and I would love to, so I will. Some of the homework problems for this section is determine where varying functions are greater or equal to 0, and let's see what I'm talking about here. Remember, if we're using the unit circle, there we go. And so this radius is just 1 here. Here's a basic picture right here. Here's x, here's y. So this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Suppose that cosine x is greater than 0. Which quadrant must it be in? Well, so for cosine x to be greater than 0, the radius, no matter what, in this case it's just 1, is always positive. It's never even 0 because a radius of 0 is called a degenerate circle, which is just a point, and you won't be dealing with that anytime soon. So basically, x has to be positive. Which quadrants is x going to be positive? It's going to be positive when it's along this line. So cosine is going to be greater than 0 in the first and the fourth quadrant. What about, so when is cosine going to be less than 0? Well, cosine is going to be less than 0 when x part is over here, like a picture's over here. Because here's y. If this is x, whatever this is right here, this will be negative x, right? And this r will still equal 1 and be positive. So cosine is going to be negative in the second and third quadrant. Well, so now that we have this, where is sine x greater than 0 and less than 0? Actually, I'll need a little room here. So sine x is greater than 0. Well, sine x is y divided by r. Clearly, where y is greater than 0, right? R is always going to be positive. So when y is greater than 0, well, where is y greater than 0? It's the top half. So any angle along the top half, or quadrant 1 and 2, this will be greater than 0. Similarly, it will be less than 0 when it's down here. So in this case, if this was y for whatever value, this will be negative y. And similarly, down here. So it's less than 0 in quadrants 3, and 4. And right now you're probably going, oh man, do I really got to know all this? Yeah, you actually do. Because we're coming up to some other stuff. What about tangent? Where is the tangent of some angle? Okay, we'll use x because we're using x greater than 0. Tangent is x divided by y. Basically, for this to be greater than 0, either x and y are both positive or x and y are both negative, so the negatives cancel out. So tangent is greater than 0 in the first and third quadrant. Tangent x is less than 0. Well, one of them has to have a negative sign. And we can do that in this quadrant. The x will have a negative sign, the y won't, so it's negative. In this quadrant, the y will have a negative sign and the x won't, so it's going to be 2 and 4. Similarly, where is cosine, or where is, so now, what about secant? Where is secant x greater than 0? Well, we already have everything we need because secant x, this is just 1 over cosine x. Clearly, 1 isn't going to affect it. This is going to be greater than 0 where cosine is greater than 0. It's going to be less than 0 where cosine is less than 0 because it's just flipping it around. And similarly, cosecant x is going to be greater than 0. Well, this is just 1 over sine x. Well, so we already know that sine x is greater than 0 in section 1 and 2. That means that this will be greater than 0 in 1 and 2, and similar. And I'll just write this up again. 1 over tangent x is equal to cotangent, since it's greater than 0. So basically, the thing about, the most important thing is to know your cosine, sine, and tangent. Because once you do, you can figure out everything else about every other function. Actually, you just need sine and cosine, really. It all breaks down to sine and cosine. All of these can be dealt with in terms of sine and cosine. Because this is equal to cosine x over sine x. And once you become familiar with sine and cosine and how they behave, you get a lot of power out of these. Okay, so we are going to define all 6 trigonometric functions at a certain point. And I'll show you what I mean. And you'll definitely want to be feeling comfortable with this. So I'm going to draw up a nice picture. And a lot of your problems are going to be very similar to this. They're going to say, here's some point, x1, y1 in the coordinate plane. We'll just say it's here. They're going to say, figure out what all 6 trigonometric functions are at this point, and here's some alpha, right? And so this is y1, this is x1, for whatever they are. And so right away you know that this is x1 squared plus y1 squared square root. And so, for instance, the cosine of this point, which is at an angle alpha, is just going to be this divided by this, which is x1 divided by x1 squared plus y1 squared square root. Similarly, for all of the other functions, it's time for us to take a break so we can get this loaded up to YouTube. And the good news is I'm going to use real numbers for a change.